Bismillahirrahmanirrahim. Let's go over the second lecture of state feedback control, and we'll go into detail of observer design. What is observer? In the last lecture, we discussed the state feedback control, the advantages of state feedback control. And the main advantage is that we can place the poles at any position of our choice if we have unlimited, unbounded input, and if the system is controllable, we can place the pole at any location of our choice. So, and we did one example of state feedback control where we did calculate the gains. This is a system, and we got access to the states, system states, and we calculated the gains of the controller, and we just fed back the states multiplied with the gains, and we said the system will be, and the response of the system will be as per our desire. Now, this is what we did in the last lecture. We calculated the calculated k values. K is a vector for a multi-state system, and then we calculated the values of the k in our previous lecture. Now, suppose we have a system and we don't have access to the state. Then what we do means, we have a system like this, GS, and we got the system output Y. And we don't have access to the system states, but we are measuring the output of the system, and but we want to implement the state feedback control. We want to implement this K, and we want to multiply the states with this K, and we want to use the advantages offered by the state feedback control. So, but we don't have access to all the states, but we have some measurements of the system, and we want to add some mathematical component over here, which can give us the state values as the system output, and we can use those states which are not directly measured from the system, but those are those values of state are calculating from the output of the system. So this mathematical component is observer. Before designing the observer, we let's go over some notion of what is observability. Observability is the quality of uh, is the capacity of the uh, output from a system uh, that it can be used to calculate all the states or the unique value of the states. So observability in technical term is that if we define it in technical terms, then it is the states of system can be calculated using system output. Means I got some output, and I want to somehow calculate the value of the states. And the if out there are enough output such that the state value can be calculated, a unique value of the system states can be calculated, then system is observable. And it is very clear, actually, this notion is very clear from the uh, meaning of observability, that we can, if we have the output of a system, we can successfully calculate a unique value of the system states. And not only actually the states, we can calculate the value history of the states, and because of the history, actually we can calculate the initial value of the states accurately. So just like controllability, let's go over some example. Suppose this is a system. Uh, I got a electric circuit, and here is a voltage source, and I get a resistor, capacitor, resistor, inductor, and a capacitor.